Hello, my dear students. Welcome to lecture number 20 on light, reflection, and refraction. In today's lecture, we are going to solve some problems, and by that, we can conclude this topic. It's a large topic and most important for the sake of examination. So, it is up to 20th mark. Okay. So let us try to understand important parts in the problems which is based on refraction of light. We will solve some problems on refractive index, similarly focal length of a lens as well as power of the lens. So the first problem is on refractive index. So here light enters from air to glass having the refractive index of 1.50. So light is entering into the air, from air to glass, which is having the refractive index of 1.50. What is the speed of light in the glass? Given that speed of light in vacuum is 3 into 10 to the power 8 meter per second. So let us try to analyze the problem here. So assume this is a glass slab. So where the light is entering into air medium to glass medium. Okay, light is entering into air to glass. You just take it as air and this is glass. Okay, so try to get the given things or given parameters right. So what they have given, light is entering from air to glass means refractive index of glass is given. Refractive index of glass, you take it as n subscript g, which is indicating that refractive index for glass, that is 1.50. And they are also given the speed of light in vacuum. Speed of light in vacuum, that is simply c is equal to 3 into 10 to the power 8 meter per second. So what they have asked, speed of light in glass is equal to how much? Speed of light in glass, in the medium of glass, v subscript g, which is indicating that speed of light in glass, which is equal to how much? So the solution, refractive index of any medium is given by any medium which is equal to speed of light in vacuum divided by speed of light in the medium, speed of the light in the medium where it is traveling. So what you need to do, refractive index of any medium, here it should be glass, you take it as Ng. So the refractive index of any medium here, that is medium which is glass in our problem, Ng is equal to speed of light in vacuum, which is taken as c, divided by speed of the medium, yet again that is the glass. So I took it as Vg, which is our main point to get. So Ng is equal to c by Vg. By just rearranging the terms, we want Vg actually, the speed of light in glass, which is equal to c divided by Ng, refractive index of glass. Again, so you go on simplifying. C is 3 into 10 to the power 8 meter per second divided by Ng is 1.5. That is the constant. I mean it is a index, therefore Therefore, no units. Vg is given by, that is equal to 2. 3 by 1.5 is 2. 2 into 10 to the power 8 meter per second. So this is your result. So speed of light in glass medium is 2 into 10 to the power 8 meter per second, which will be your first problem. I hope you got this problem right. So the next problem, that is based on convex lens, its image as well as focal length along with the magnification. A 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter. A 2 centimeter tall object which is placed perpendicular to the principal axis of a convex lens of focal length 10 centimeter, which means you just try to draw a convex lens, write the principal axis. So a 2 centimeter tall needle which is kept perpendicular to the principal axis of a convex lens of focal length 10 centimeter. So this will be your optic center O. This is your F1. Assume this is 2F1. Here it is F2, 2F2, no problem. So the distance between F1 and O will be your F, that is nothing but 10 centimeter, and this is the height of the needle, that it can be taken as H. The next point, the distance of the object from the lens is 15 centimeter. So the object distance from optic center to this point is of 15 centimeter. You take it as U. Find the nature. What will be the nature of the image, position of the image, and size of the image. You need to calculate what will be the image distance first. By that you can get the nature and size right, along with the magnification. So try to write the given parameters after getting this drawing right. Drawing is indicating that how much you understood the problem right, which will be our first part of 5S tricks analysis of the systematic analysis of the problem. So here it is H, that is the height of the object, which is equal to 2 centimeter. You keep it. I will use that later. And we have the object distance U, which is equal to 15 centimeter, and we are also having the focal length F is equal to 10 centimeter. So they asked to calculate what is V, the image distance, along with the magnification M is equal to how much. So please bring the sign conventions here. So H, that will be the object height. It cannot be negative, it is always plus. Height of the object is plus 2 centimeter. Object distance is taken as minus because it is on the left hand side, so it is minus 15 centimeter. Focal length is plus 10 centimeter because it is a convex lens. So convex lens of focal length, that is 10 centimeter in this case, which will be plus, because we got that the focal length of a convex lens is positive and focal length of concave lens as negative. Using that conventions, I am using these things plus or minus. So first step is to get solution. First step is to get the image distance V. We need to get the image distance V first, and later we will check what will be the magnification. So we know from the thin lens formula, we know the formula for thin lens, 1 by f, which is equal to 1 by v minus 1 by u. So we know this formula very well. So bringing that in, because we want this v, f, we want actually v, therefore just I'm keeping 1 by f here, sending 1 by u on this side to get 1 by f plus 1 by u, which is equal to 1 by v. Just go on solving this to get for v 1 by, again you have two methods to get. Either you solve this formula to the simple one to get v, or you just substitute the values here, no problem. I am following this because I like this type of method well, therefore I'm using that. So 1 by f plus 1 by u here, sending u on this side, u plus f. So u on this side, f to this side, by getting these two right, fu, and rearranging the terms for v, you will get v is equal to uf divided by u minus f. So get the values of u and f here to get v. So u is minus 15 centimeter. So f is plus 10 centimeter divided by minus 15 plus 10 centimeter in common. So v is equal to minus 150 cm square divided by minus 5 centimeter. Centimeter, one of the square of the centimeter cancel each other, minus minus cancel, 5 ones are 5 30s are. Therefore you left out with v is equal to plus 30 centimeter. So I mentioned in the earlier class that image distance in case of convex lens is always positive. So if you got those tricks right, these type of formulae, these types of problems will not give you any confusion. If you are sticking to that, so I believe there is no problem at all. So plus 30 centimeter, what it is indicating? So image formed is at 30 centimeter from the optic center. Image is 30 centimeter. Nature will be real and inverted. Real and inverted here, and you are having the enlarged image. Image is enlarged in comparison with the object. So our next step is to get the magnification, right? So to get the magnification m, what we need to do, we have the formula yet again, m is equal to h dash upon h, which is equal to, you can write v by u, which is understood, we already done that. Therefore h dash, I can write h dash upon h, which is equal to v by u into, that much. So sending h on this side, h dash, which is equal to v by u into h. So substitute all the values over here. So what you are getting? H dash is equal to, v means we already got 30 centimeter divided by u is minus 15 centimeter into, that is h, which is 2. We already know that 15 ones are 15 twos are. So MCM get cancelled. H dash is equal to 2 into 2 minus 4 centimeter. So you will get the image h dash is equal to height of the image is minus 4 centimeter. Minus 4 centimeter, the negative sign here, it is indicating that the image is real and inverted. So the justification of real and inverted image is for this, because we got negative value of h dash. So h dash, the height of the image is minus 4 centimeter. By that you can get the magnification here. So make use of the same formula here, h dash upon h here, which is equal to h dash minus 4 we got, and we got 2 centimeter for height of the object, and hence m is equal to minus 2 value, because centimeter cancel each other. So the magnification is 2, which is indicating that image is doubled the size of the object. So minus 2, which is indicating that h dash is means height of the image is minus, therefore m is minus. Okay, so this is all about this second problem. The next problem: a convex lens forms a real and inverted image of a needle. So a convex lens forming a real and inverted image of a needle at a distance of 25 centimeter from the lens. So we have the image distance this time. If the image is same size of the needle, then where should be the needle placed in front of the lens? Where will be the object distance from the lens? They are asking the object distance is equal to how much, and also calculate the power of the lens. So for this kind of problem, you need to understand the theoretical aspect right, otherwise which is impossible to solve such kind of problems. Okay, so a convex lens is forming a real and inverted image of a needle at a distance of 25 centimeter. So here you just, so let us have the solution. As per the given problem, the image is formed at 25 centimeter from the lens, means v is equal to 25 centimeter. You are having the image distance is 25 centimeter. What they have mentioned, if the image size is same as that of needle, means we already aware that when we place the object at 2f1, we will have the image at 2f2. So as per the given problem, the image is formed already at 2f2, which is v is equal to plus 25 centimeter. Okay, so v is plus 25 centimeter, which is already mentioned as per the problem. So here, once you have the image at 2f2, object will be having same size, and hence you can write u is equal to minus 25. U is equal to minus 25. Why minus? The object is kept on the left hand side of the optic center, therefore u is taken as minus 25 centimeter. I hope you understood this part of the problem, right? So we are having the object which is kept at 25 centimeter from the lens. Okay, the minus sign which is indicating that, which is on the left hand side of the lens. So our next step is to get the power of the lens. So to get the power of the lens, what we need to do to get the power of the lens, we need to calculate the focal length of the lens. So we know that focal length of the lens, which is given by 1 by f, which is equal to 1 by v minus 1 by u. Therefore, you keep it for f now. So try to solve this part. 1 by f, which is equal to u minus v divided by v into u. 1 by f, which is equal to u minus v divided by u into v. Therefore, f can be written as uv divided by u minus v. So, focal length f is equal to u is minus 25 centimeter and v is plus 25 centimeter divided by minus 25 of minus 25, that much of centimeter in the denominator. F is equal to minus 625 cm square divided by minus 50 centimeter on the denominator. So 1 cm and square of 1 cm cancel each other. F is equal to, and minus minus term cancel each other, 50 ones are and 15 ones are 15, 12.5 are, if I am correct, that is 12.5. So plus value here. So F is equal to 12.5 centimeter. So we will have F is equal to 12.5 centimeter. So you just try to write it in terms of meter. So 12.5 centimeter means 12.5 into 10 to the power minus 2 meter. Therefore, power of the lens is given by power P is equal to 1 by F, which is equal to 1 divided by 12.5 into 10 to the power minus 2 meter. Therefore, P is equal to so here 10 to the power minus 2, sending on this numerator part, you will have 10 to the power plus 2 over there divided by 12.5. That much of meter meter on the side, no problem. So 100 by 12.5, which is equal to 8 diopter. Therefore, power of the lens is equal to plus 8 diopter. So this will be the power for the lens given. So these are all bit complex problems. So once you got practice enough, you will solve all these kinds of problems correctly. Okay. I am hitting into the last part of the problem, and hence the last part of the chapter as well. A doctor prescribed a corrective lens of power plus 1.5 D plus 1.5 diopter. Find the focal length of the lens. What type of the lens is prescribed by the doctor? Again, here we are having the power value. Power P is equal to plus 1.5 diopter. So focal length of this is equal to how much? So F focal length can be written as focal length F is equal to how much? We have power P is equal to 1 by F. So what you can write? F is equal to 1 divided by P. That can be done. So F is equal to 1 divided by plus 1.5. which is equal to F, which is equal to 1 divided by 1.5, which means 1 divided by 1.5 plus 1.5 means it is plus 0.66 meter. So F is equal to 0.66 meter. That will be the that will be the focal length of the lens, since the focal length is positive, and hence it will be a convex lens. Since focal length is positive, also power is positive, which is indicating that the prescribed lens given by the doctor will be convex lens. I hope you got all these things right. If you are having any queries, we are always with you. So I'm gonna pause here at this point of time. This will be the end of this chapter. Thank you for watching and being with us. Bye bye.